Hello, in this video, I'm going to redo one of my IKEA air quality sensor projects. The previous one worked fine, but the CO2 sensor was a little bit off, and I've recently found a new sensor that I'll be using instead. Also, I'm using these ESP32-C3 boards now. I find them a lot better. They're smaller, they're USB-C, and although it doesn't have as many GPIO pins, I think for smaller projects like this, these are ideal. Soon after the original tutorial, the comments started coming in about the CCS811. These sensors only estimate CO2 based on VOC and other stuff. So I got a proper reference device, the £170 RNet4, and started testing with other ESPHome sensors. Let's talk about why the SCD-30 tips the scales. First of all, the SCD-30 uses true, non-dispersive infrared technology for CO2 directly. Not estimated, not calculated from VOCs, actually measured. Plus, temperature and humidity on board. So that's 3 sensors on one board. This thing matches the accuracy of the £170 commercial grade RNet4 monitor. All that, and it just weighs in at £10. So yeah, that works. Here's a history graph with the RNet4 in blue, desk which is in yellow, which is my test setup, and one of my original IKEA units, Studio, in orange. As you can see, Studio is way off at times, and the SCD-30 in yellow is pretty much in line with the expensive RNet4. And I set the SCD-30 to every 30 seconds. But when they do line up, they're pretty much the same. Say goodbye to the hassle of dealing with multiple vendors and save time by getting your PCBs made and assembled with PCBWay. PCBWay offers reliable PCB fabrication and assembly services, as well as 3D printing and sheet metal fabrication, all in one place. With their great prices and high quality components, PCBWay is the go-to for all your electronics projects needs. Experience the convenience and reliability of PCBWay for your projects. Head over to PCBWay.com now to learn more. Right then, let's convert this thing. This one I've got from the bedroom. Let's take it apart, pull everything out of it, and get the new stuff in. As you can see, this one has got the D1 Mini in it, and the 2 sensor boards there, which is the CO2 sensor at the back, and the BME 280, which is temperature, humidity, and pressure. I'm also going to get rid of the light sensor. I never used it. I don't think any of you did either, so that's pointless. First thing to do is get these sensors out. Now, I used hot glue in the previous one, so as you may know, a bit of ISO alcohol. We'll melt this glue, or release it at least, and you should be able to, once it's soaked in a little bit, just pop them off, which is nice. So let's also get rid of the fan and the sensor, put this one side. So like I say, we're going to get rid of this light sensor. I'm just going to take this board off for a second, because that green wire, I soldered to the sensor there, so let's take that off. Not going to use that anymore. Just very quickly, we don't want to melt that sensor, because the IKEA unit still uses it. It changes the LEDs on the front there. Right, so let's put that back in. Corner there first, and then we can screw these back in. That's that bit done. I'm going to keep the wires on the boards. So what we need to do is desolder everything off this D1 Mini now. So let's take that blue wire off. The brown wire was the fan, and then we've got the 2 5-volts of ground. Like I say, we're not going to use the CO2 sensor, but I am going to use the BME 280. I'm not going to use its temperature and humidity sensor, but I do like the pressure. Now, you don't have to do this if you don't want to. The new sensor has temperature and humidity on it anyway. So let's take that link wire off, and we'll take all of these off as well. Because what I'm going to do, if I don't burn myself, too late, burn myself, is I'm going to release this sensor from the CO2 sensor. And to do that, I'm quite good at holding this down with my fingers, so you may want to clamp this.
Open a window, it's about to get smug in here.
What I'm going to do is I'm going to put a load of solder on here, and then I'm going to run backwards and forwards, keep those pins, get those pins nice and hot, and then hopefully, if I do that, nearly came out, so a bit more working on those pins. There you go. That's the old CO2 sensor. Not going to use that anymore. And we just want to clean up these pins a little bit to get some of that residue solder off. Just heating that up. Shouldn't take too much. They're quite hot at this point. And we'll just rub the solder off of these. Cleaning the iron in between, because I'm hoping that the iron will pick up some of the solder. I'll just rub that off, and then when I come back to another pin, it'll pick up a bit more solder. Another wipe. That should be okay. Right, D1 Mini. You can erase that, throw it in the bin, do whatever you want. The new sensor is this little thing. These are the Sensoron CO2 sensor. It's got a couple of little ports there, I think, and some other vents there that suck in the air for the CO2. That thing there is the temperature and humidity sensor. The whole thing's on an I2C bus. If we're looking at the back, we've got the voltage in, ground, and then SCL and SDA, which is our I2C ports. And if we look on here, we can see this has also got voltage in, ground, SCL, and SDA. So they're the same. So again, like we did with the old sensor, we can match these up. Now, I'm not going to put it this way because the board's going to stick out. I'm going to rotate it this way and put it in that side. So it looks like I've got a bit too much solder on that pin there. Let's see if we can get that off. Hopefully, it'll go in there. Yep, there it goes. So as you can see, we've got voltage ground at the top, SLC and SDA all match up quite nicely. Let's get these soldered together. It's always going to be like that, so don't worry. On each one of these pins, just melt it a little bit. Just keep them flowing, and I should be able to just line them up a little bit there. Lovely. I'm going to put this in the case this side. Our ESP32 is going to go on this side of the case now. So I want wires coming from here to here, and just to keep everything nice and neat, I'm going to solder onto the top of these pins here. So get some wire. So don't really need it any wider than that. And we'll just get these tinned. And as I always try and do, nice blob of solder near the insulation. So when I cut this off and trim it down, I've got a nice blob of solder there. Okay, so first one there is the red wire. And what I'm going to do is I'm going to hold these two together, get a little bit of solder on my iron, and then I'm going to touch the pin and the wire together, and that'll bridge the solder. So the wire's sticking directly up, like so. I'm going to do the same for the black here. So again, blob of solder, nice and gently, touch those two together and melt the solder between them with the iron. Next up is the I2C port. I'm going to do the same thing. I've already got the wire measured here, so I can just pull that out a bit more. Blob of solder to the insulation on both of these. First one there is SCL. SCL, I'm going to put the yellow wire on. Again, clean my iron. Little bit of solder off camera there. After each solder, just check it, just to make sure they're on there. Same thing again. Clean my iron to get some previous flux off. Blob of solder. But it's on there. As long as the solder has melted onto the pin and the wire, and obviously they're not touching between each other, then that's fine. And that's it. That's pretty much all the sensor set up, ready to go. Next thing I'm going to do is I'm going to flash the code on my ESP32 board, just check that it's working okay before I solder all the wires on. I found some of these boards, just if you buy them cheap, they do have problems with Wi-Fi sometimes, and they go into a boot loop and everything else. I get my boards from AliExpress. I'll leave a link in the description. These 10-star boards, I've never had a problem with them, and they've also been quite reliable as well, long term. Right, so in ESPHome, I've already got the air quality monitor for bedroom. So what I'm going to do is I'm just going to update the code on that. On the GitHub page, you'll find an extra YAML. And the first section, we've got the standard boilerplate for the name, Wi-Fi, etc. The RX pin there, that's for the particle sensor. That's now on GPIO 20. That's good to see. That's now on two different pins. And this is for the SCD-30 and the BME 280 that we're using the pressure from. Next up is the binary sensor, the GPIO 8. Like I did before, I'm just using this to light up the onboard LED when the fan's running. Not strictly necessary, it's just a nice touch. Same code for the particle sensor that's inside the IKEA unit. We haven't changed anything there. CO2 sensor now is the SCD-30, and this one's got a little temperature offset. Obviously, this is inside the case, and most CO2 sensors will need a temperature offset so it knows the environment that it's testing in. I don't know, it's something to do with the heating element. And then I've used an offset of 2 for the inside of these IKEA cases. It seems to work well comparing it to the RNet. I recommend you stick with 2. If you've got a calibrated sensor, then put that next to it and adjust this as necessary. As I say, this sensor gives us CO2 as well as temperature and humidity, so I'll be using those. And the BME 280, again, don't have to include it. I had it anyway, and so I thought, why not? We're doing temperature and humidity from the CO2 sensor, so I'm just using the pressure. And then finally, we've got the CO2 calibration. Now, this is a lot easier than the previous sensor because this is all done in Home Assistant. There's no need to reflash it once you've got a baseline. So calibration on this unit consists of 2 items. We've got the number, which we use to input a baseline, and a button that we use to actually set the device. And you'll see that when we do the calibration later. So I'm just going to copy the raw file here using the copy raw file button. We'll paste that into ESPHome and we'll get it flashed. This one's going to be plugged into my computer. So let's open up ESPHome. We'll plug it in like so. You may be able to see that or not. There's a blue flashing light on there. That shows you that the ESP chip is running because that's a demo code that's on there. Another thing I like about these boards, You don't need to hold down the boot and reset button. You can just program it once you've plugged it straight in. Nice. Okay, that's connected. Let's connect. We get that ready to install. Let's go back to here, and we'll just wait for that to download.
I need a time lapse. Time lapse.
It's finished. Let's download the project. We want the factory settings. We want that on my desktop so I can find it easily enough. We can close that down there. Cancel that. Go back to the web view. As always, I need to keep that. So in the web browser, I'm just going to drag that firmware onto there. Let's bring up the thing. Doobly doobly. But we'll turn the light down because it's always fun. And we'll hit install. But yeah, there's a light stopped flashing. I didn't press any buttons. It went straight into erasing and uploading the code. Obviously nice and fast there. So next up, I'm going to unplug it and plug it back in again. Get rid of that. You can close that down. Air quality monitor bedroom. That's this little thing. It's running. It's connected to Wi-Fi. We'll just verify that. Obviously, that's going to mark as failed because there's nothing connected to it yet. But it's all connected. Right, so that's running on the Wi-Fi now. I should have done this before, really, because I already had the sensor. Oh, it's found it. Before I add that, I'm going to make sure that the old one isn't still in my ESPHome device list. We're opening up the ESPHome integration in the home system. Let's search for the air monitor bedroom. Remember, this is a D1 Mini unit that I'm replacing, so I want to get rid of that. Obviously, if you're making this for the first time, you won't need to delete that because you shouldn't really have it. So the air quality bedroom, I'm going to add that in or submit that. This one's obviously going in the bedroom. So we won't get any sensors yet because, again, they're not plugged in. Right, another thing I need to do on my version, because I'm using automations, if I go down to air monitor bedroom, I need this to be able to control devices in Home Assistant. So remember that automation, it's sending speeds to the fan. I'll get an error when the automation fires if this thing isn't on. So this is allowed device to perform Home Assistant actions. So I need to make sure that's on for me. Again, if you're using automations, you will need that on as well. That's all I need to do there to add it to Home Assistant. So what I'm going to do is I'm just going to open this up. And what we'll do now, we'll go back to the bench. We'll solder the sensors onto here. All this will populate. So let's unplug it and go back to the bench. Hello, and welcome back to the bench. Let's get these wires connected. Most of these will be the same length, so I'm just going to trim those off so they are all the same length. And let's strip those. Let's spread them out. So we'll spread them out there. A little bit of solder, like we did before on the other ends, on each one of those. On ESP32, let's do 5 volts and ground, which is on that side. So a blob of solder on there, 5 volts, ground. 6 and 7, which is our I2C bus, which is on this side. So that's those two. Turn it round. We see that 6 and 7 are on this side. Those two there. So let's put a blob of solder on there. So 5 is the top. And we want 6 and 7. Ow, that's hot. Again, on that same side is number 8. That's the onboard LED and the fan. So a blob of solder on there. Because I touched that while when I turned it over, I'm going to redo that. For the code, GPIO 20 there. That's the serial bus that the particle sensor uses. Okay, let's do the I2C bus first. So in this setup, down the bottom there, 6, 7. I'm going to do it the other way around because I'm left-handed. It's always better for me to work across this way. So I don't want 8. I want 7 for the yellow. And again, we're going to make this vertical. Give it a little blow there to cool it down. White wire is going to go there. Now another little tip here. These are called castellations or castellations. You can see there we've got the hole there where you normally put the wire through. And there's also like a little Pac-Man mouth there. That's where I'm putting the wire. So I'm putting the wire on the side of the board and heating the wire through to the solder underneath. That doesn't look very good. Let's fix that. I'm just going to take that off and resolder it. That's better. Right, so the power supply. What I'm going to do first is I'm going to click the red and black that's coming off the board. That's the power supply for the whole system. And what I've done here is we'll check the board. So the top one's 5 volts. I'm going to take the red wire, which is 5 volts coming in. And what I'm going to do is shouldn't really solder this pin though, because she made your life difficult. Don't solder the pin when you do yours, so the hole's open. So you can put your wire through like that and solder it on the back. Now I haven't, because I'm an idiot. So I'm going to try and get this wire through that hole that's already got solder on it. So I'm going to melt the bottom, and I think success. Okay. Let's see if you can do it again, Dave. Challenge accepted. So I'm going to heat it up and very gently poke it through the hole. I mean, okay, that's not all the way down, actually. Let's do it again. Push that through a little bit more. Yeah, can we see that? So your wire will be through the hole and you'll just solder that properly. The red and black wires coming from the sensors, these ones are already filled up with solder on this side. What I'm going to do is I'm going to hold the wire over that C shape, and I'm going to melt the solder on the wire so the heat goes through and goes into that little groove there. And then obviously the same for the red wire. And then that way I've got 2 reds and 2 blacks on those pins. Right, next one is the brown wire. That's the fan. And again, like an idiot, I put solder on pin 8, and I also did pin 20 as well. So leave all your pins open until you're ready to solder. So again, let's try this. Solder through there. That's almost through, but the solder didn't flow, so I'm going to put another, just solder that properly in there. And then finally, we got the blue wire, which is the sensor data coming from our fan. So I'm going vertical anyway, so what I'm going to do is I'm going to fill up that C thing on the side, and then my blue wire, I'm just going to connect into that half circle. I mean, that's there. And everything is ready to go. Before we put it back in the case, I'm going to plug it into Home Assistant and see what happens. Back in Home Assistant, we've got the devices and services opened, ready to go. Let's plug this in. Wait a minute. Let's not plug it in just yet. Let's connect up all the sensors. So let's put in the sensor for the IKEA and its corresponding fan. I'll put it on its side because it sucks in air and blows out there. And then we'll plug that on. And let's see what we get in Home Assistant. Right, there we go. We've got the particle count. We've got the pressure from the BME. Hopefully the CO2 sensor is working. Remember, it's set to 30 seconds, so we might have to wait 30 seconds for that to get its first reading. Oh, there we go. It's working. So I've got CO2 of 0. It's a bit worrying. I've got humidity 49 and temperature 27. 27 in there? Might be because of the soldering. So now the CO2 sensor, I did notice when I was watching this, every time it reads, this little area there lights up. Let's turn that down a bit so we can catch the next one. And we can see here, well, we've got a reading. There we go. Lovely. So I've got 9,000. That may be correct, actually, because I've been breathing on it. I've got solder on and everything else. But we'll do some calibration. Yeah, so 40,000. I don't think that's right. Okay. That's going to need calibrating. Well, it's dropping, at least. Right, so the sensor's in. Let's do some calibrating.
A few moments later.
As you can see, all the levels have gone down. So I took a break, turned the solder line off, opened the window, run the fan. Obviously, I was breathing on this. Fumes from the solder line and everything else affected these readings. Calibration. As you can see down the bottom, we've got 2 items in the configuration. We've got the CO2 calibration and the baseline. Unlike the last one, we had to edit the ESPHome code. Here we have a button. Next, I'm going to put all this back together, and then we'll hang it out of the window and get it calibrated. Right, with the hot glue warming up over there, a little bit more iso alcohol. I got rid of the hot glue remnants that was in there. And I've also scratched this side to give the hot glue a little bit more purchase. Let's start with the sensor. What I'm going to do here is hot glue will stay hot for quite some time. So what I'm going to do is I'm going to put a blob of hot glue down there. We'll take our sensor, and I'm going to, I don't want to block up these holes. So just make sure that we don't get anywhere near that. And I'm going to shove that sensor on there and push it up against this bar here, making sure that nothing goes in that hole because these posts need to go down there. So that's the base in, and I'm just to secure it, I'm just going to put a little blob of hot glue on that corner, and we'll just wait for that to solidify. I could try blowing it, but you know what this stuff's like, it takes ages to cool down. For the ESP32, that's going to go on this side of the case over there, and I want to make sure I can still use this USB later on. So what I'm going to do is I'm going to plug in, this is fairly small, but grab your usual USB-C, unplug that to get it out of the way a little bit more, just gets that wire out of the way there. And I'm going to do something similar. We'll put a blob of glue along the bottom there, and I want that lower than the edge. Again, up against that rail, so a bit of glue on the bottom there. Just hold that down, and as you can see, I've got a nice lot of space there for the USB plug. So with that still in place, and then we'll just put a blob in there, quite a generous blob. I want it to go over the edge of the board as well. And then we'll just wait for that to cool down. Time lapse. Okay, that's kind of stuck, so we'll hold that down, get that off there gently. And I'm just going to put a blob in this corner as well, just to make sure nothing comes loose. Yeah, again, underneath, and it's slightly over the top of the board as well. And then we'll just make sure there's a little ridge here on the side. That's obviously going to go in here. So just make sure that fits. Feels quite nice. Right, check it back in Home Assistant, and we'll continue with the calibration. Now that's all back together, let's hang it out the window and get calibrated. I've added a bit of tape here, just so I can hang it from the USB connection. And then once it's outside the window, I'm going to watch this temperature until it levels out. So I'm going to be looking at this graph here. I'm not going to use this one because it's aggregated every 5 minutes. If I go show more, that will show me the history graph, which is more up to date. So what I'm going to do is I'm just going to simply zoom into that last section and we'll watch this graph for it to level out. After all that soldering and hot glue gun work, the temperature of this sensor is going to be skewed. So I'll hang it out the window. That should cool everything down. 11.6. Oh, that's been for quite some time. Okay, that's level. Let's go back to our sensor and see what the CO2 reading is. It's not gone down to 400, which would be ideal. Normally, I'd calibrate my sensor like 2, 3 o'clock in the morning when there's hardly any traffic. Most people's central heating has gone off, but we can use this number, 637.8. I'm going to round that up to 638, and then we'll hit calibrate. And if I check the logs on ESPHome, we can see that false calibration has been complete there. So that's good. And there you go. That's how you calibrate it. Well, I hope this video was helpful with your projects. Please do share it so others can find it as well. I upload videos whenever I can, so subscribe and hit the bell icon to get notified. That's it. Thanks for watching.
Okay, I love you. Bye-bye.